Hi everybody, this is Sam with Python Basics, and we are going to do another little quick series, and I hope you guys don't get too bored with this, but it's going to be sorting list of lists, but this is actually going to test, this is an algorithm that's going to test the 25 horse race interview that I've seen floating around on YouTube. So, okay. I didn't really grasp the concept, and then also I wanted to make sure that it was accurate. So, alright, here's the premise. What it is you have 25 horses, and they are mixed, and you want to find the fastest three. So, alright, so I wrote an algorithm that is going to test this, and what the premise is you have, and you can only race 5 horses at a time. So you break them up into 5 groups. So actually last video we did this, and then I decided to go ahead and do this one. So okay, here's the idea. The fastest 3 should always live right here. So you break them up, you sort them this way. You have the 5 horses, then you sort them this way, then you remove 25, and if you have this as a triangle, if you look at this, you group them here, you have that one, then you have these 2, then you have the base of 3. So you have 1, 2, and then 3 more. So if we grab and we draw a diagonal line right through here, these should always be the top 3 horses in this little triangular area. So as we see right here, this works. But let's build an algorithm that can test this every single time. So alright, that's the idea. So now to do this, we're going to use random, and the actual one that we're really going to use is, that I'm most interested in, is shuffle. And what shuffle does is it takes a list and it mixes it up, and literally like a deck gets shuffled. So let's just take a second and look and see what shuffle does. Alright. Well, let's just remind you, we did one on random. Alright. The ones that we've stuck to were random and randint. So shuffle right here. So help random dot shuffle. So okay, takes in an argument. Shuffle list in place, return none. So this is important. Let's go over what this means. It's not going to create anything new. I'll say this again. Return. That's another. It's going to not create. Not going to create anything new. Shuffles in place. So you do not have to assign this to a new variable. This is just going to do it. So let's look and see what we want to do. So we imported random. Then we have 25 numbers. So let's just create a list of 25. Then we're going to do range, and we want 1 through 25. And then there we go. Now we want to shuffle this. Well, let's actually go ahead and create our end result, because this is what we're going to pull from place. Then I want to, so this is where we're going to pull these from. This is where we're going to put it, and then I want to show you. This is going to be like our last little bit to test our if 23, 24, and 25 always end up in there. So now we need to create something that's going to hold our lists of lists. So let's do list comprehension. and we want 5 of these. So the way to look at this is I want this done 5 times, and I want a empty list created. So alright, let's take a second and look and see what we've done so far. So alright, 25, there's our list. Then we have our X, which is going to grab our last ones to see if it's truly slices, and these are always contain 24 and 23. And this one is where we're going to shuffle 1, 2, 3, 4, 5. So that contains our 5 races, or our 5 lists. Now let's shuffle this. So right here, here's our 1 through 25. So now let's shuffle our list. So this is how we call, since shuffle lives in random, shuffle, and we're going to put in our argument of 25, excuse me, X underscore 25. Let's run this again. Let's call. So now if you look really close, our list is now shuffled, and it did this in place. So alright, we have our 5 races, and we have our shuffled right here. So now we are also going to utilize the pop method on lists. So not only and we're going to do this just like a deck. So let's look at what pop does. So it literally removes it from a list and puts it someplace else. Doesn't matter. And that is an action that Python automatically does for us. So it copies and deletes at the same time. So it's a nice handy tool. So let's just look at it for a second. So alright, remove and return item. So this is what we're going to do. We're going to keep this real simple. So we're going to go through, we're going to do something 25 times. So we're going to do this with 2 for loops. And I'll go over this real slow what we're doing. Alright, so dot pop, and then close this out. So okay, we're gonna do this 5 times, then we're gonna go through our lists 5 times. So 1, 2, 3, 4, 5. Drop this in there and then repeat 5 more times. So we're going to split our shuffled list right here into 5 different races, and we want this just to be randomly picked because we want them dispersed, because we want to test and make sure that when we sort these, when we find the fastest horse, or when I thought about this, what would be the difference of having numbers, so then it would be quantifiable and we could literally visualize it, because I have to see things to test them to see if this is accurate. So lo and behold, when I've done this, it has worked out. So alright, let's look and see what we're really doing. So we go through this one time, do this one time. So then we're going to say, go through each of these lists and pop one out of here. And also, let's look right here. What pop defaults and does. Reason why I have no arguments in pop, because look, it says place an index, which is optional, and if it does not have an index, it defaults the last item. So literally what this is doing is it's grabbing the last item out of here and just popping it in the list. So just keeping this real simple, but let's go through what this is doing. So the first time through, this says do this 5 times. So the first time through, go and take a number, pop it out of this list, and place it at the end of tab, which is here's tab. Then the first time through, this is 0. So pop up 1 out, put it in 0. Then the next time through, put it in 1, put in 2, index 2, 3, 4, so on. Then repeat. Then come back up here, then go through again. Grab another number, put it here, 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 and here. So I can say all that. Let's just run this and look at it. So let's call tab. So here we go. Let's run a nice little loop on this for tab, and let's just look at it. Print I. Okay, this is a lot neater. So now we have 1, 2, 3, 4, 5. 5 lists with random associated numbers that we now need to go in and sort. So now let's sort each of these lists. For I in tab, I dot sort. If I could spell today, let's run this one more time. Call tab. For I in tab, print I. So now they're in ascending order. So we basically ran the first races, right? So now we have our lists in order. But last video series we learned how to sort these in order by the last item. We're just going to jump right in and finish this out. So again, if you have not watched Sorting List of Lists, it's the series before this. Go and watch that, and then come back and watch this. So x return x minus 1. Then we need to tab. We're gonna redo this in place. Sorted tab and key last, and then we need to reverse it. True. And let's check and make sure. Let's run this for I in tab, print I. So lo and behold, here we go. So, and to remind you what the premise is that out of these, well, okay, so this is supposed to be the fastest horse, which every single time, and I have this printed and nice formatted, and that's actually, I'm going to do that so you can see it each time. So, okay, this is supposed to be the fastest horse, or 25 all the time. So we can remove this. So we have 1, 2, 1, 2, 1. So if we do that diagonal and that diagonal, so that's our 5. So that's how we can sort this last time. So now we need to come and slice this out. So this is what is odd. So let's do that. Actually, let me show you how to do this in a nice little print format. Let's do this right here. tab for J and I, then print. This is your print format, so if you don't get this or don't understand this, go and look at search print format video and it'll go into place, because this is a space holder format, and then format J with in spacing, oops, and a space in between. So let's look and see how this goes. Oops, I forgot a return. There we go. So alright, there's our nice little print. Go through, print 2 spaces, print a space in between, lo and behold. So alright, 25, so right here, and we can just run this over and over and over again. And here it is, resorted, 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 and as you can see, 25 always ends up in the top. And this is what I wanted to prove, was that does 25 always end up in the top, and does 23, 24 end up in this diagonal? So now we need to slice. Now we need to slice this, right? So now let's slice our list of lists, or our array. So it's going to be these two right here, these two, and this one. So we need to come through, and we need to then create slice tab, and this is going to be list 0, list 1, list 2, and that's as far as we need to go, right? 0, 1, 2. That's our list. So 0, 0, close out, open, then 2 through 4, because we don't want 25, because it's, so 0, 1, 2, we want 2 and 3. This is exclusive. Then add this together, tab 1, and this is then 3 to the end, 3 to the end, 0, 1, 2, 3, and 4, so 3 to the end, plus tab, our second list right here, so 2, index 2, so 0, 1, 2, and just the last item. So close this out, then 4, there we go, and then print X. So lo and behold, they should always contain print X. And we just run this over and over and over again. Alright, let's sort this over here. And then print X. There we go. So this should always end up 23 and 24 to test this theory. And you can just run this over and over and over again, and as you can find out that this does, in fact, this technique, no matter how many times you run this will always be 23 and 24, excluding this top one, because this is always going to be 25. So this does work. This is an interesting technique, and this is how, and what the answer is in in 7 races you can find the top 3 fastest horses without having to use a stopwatch. So there you go. This is just one of the cool things you can do with programming, and this is why I love it. So thanks for watching. Don't forget to click that like and subscribe button, and most important, that notification bell. And please leave any video requests below, and I will get right to them. So thanks for watching, guys, and we'll see you next time.